Here's the recipe to prepare 50 ml twice concentrated Bacteroides minima media. First, we would add water to a vacuum tube, 39.45 ml of the water. Before starting the making the media, we have to clean the bench with ethanol to prevent these potential contaminants. Spray the 70% ethanol on the bench top, wipe it with a napkin, and then turn on a flame. A benchtop flame. So we will do all these operations just nearby the flame. Here's water in a vacuum tube, and now we're going to add salts and minerals and mix with into this pure water. So open the cap of these 10x salts because it's pre-sterilized, just nearby the flame to prevent potential aerosol that contaminate these salts. And make sure we use a clean sterilized pipette tips to take out the volume in this 10x Bacteroides media. Okay, so and when we cap it back, just heat it nearby the flame again. Also the cap to ensure there's no bacteria contaminated on the opening, and then cap it. So now we're going to follow the order, adding the component, and first is a 100 milligram of the L15 HCl, which is powder, directly into the tube. And then 100 microliter of magnesium chloride. Also, we are going to use those sterilized pipette tips to transfer this liquid. These are sterilized and has a barrier in between of the tips. Those are aerosol barriers. Next is the calcium chloride, and remember to change pipette tips just to prevent contamination. Next is iron sulfate, which is also 100 microliter. Histidine hematin is in this tube I prepared in advance. So that's also 100 microliter. Here is vitamin K3. It's also 100 microliter. All these vitamins, hematin, histidine solution, they're kind of light sensitive. So since they have color like this, so they have to be stored with aluminum foil. And then B12, B12 is only 50 microliter, and it also has color, so wrap with aluminum foil. That's B12. Okay, and now we have all components in, but remember here, this tube now is not sterilized, so we have to further make it sterilized before we can put it into the anaerobic chamber. So how we are going to do that, then we're going to use this, the millipore 0.22 micron filtration membrane. So the bacteria cannot pass through that 0.22 micron filtration, so it will be sterilized by filtration. Now we just take this off. Connect it to a vacuum hose. Don't start vacuum right now. Just kind of scroll this media mix, invert it, and turn the vacuum on. Then the solution will be filtered and be sterilized. And there's a clean cap in a package. Just open it. So just be careful, because now the solution is sterilized. We don't want anything to be contaminated. We can kind of heat gloves a little bit to remove these aerosol bacteria. And once it's done, then carefully take out this clean cap. Okay, now it's done. It's finished the filtration. Finished filtering, and then turn off the vacuum first, and then kind of throw it. By doing this step, I would recommend to do it near the flame, just to kind of prevent contamination. And then take this clean cap, turn it around nearby the flame for a few seconds, and then cap it. And that's it. Now it's been filterized. Now it's been filtered and it's sterilized. So we can write a name on them. So it's 2x BMM filtered. So just mark a filter means it's sterilized and ready to use now. We just prepared a minimal media, but without any carbon source. But bacterial growth requires lots of substrates or carbon source. So for the resuscitation purpose, we can use glucose as a carbon source, since it's the simplest carbohydrates. So we'll prepare 2% glucose, and when we use it with a twice concentrated Bacteroides minimal media, we just mix them 1:1, and then it will become 1x media and 1% glucose in the final media solution. So once it's dissolved, we would also pass it through a filter membrane again to make sure it's sterilized. So do similar operation as before. Filter it nearby a benchtop flame and carefully cap it. The cysteine hydrochloride must be added freshly into the media whenever you prepare a new media, because the 16HCl is the reducing agent to reduce the oxygen content in a media, since we are culturing anaerobic bacteria. So it's very important to add this component freshly. Don't make it a stock. So now we are going to use the anaerobic chamber. We prepared the media, but there are still oxygen in a liquid, especially in the water. And the oxygen level is definitely larger than 100 ppm, which is not suitable for anaerobic cultivation. So we have to put this media into the chamber at least overnight, according to my previous experiments, to let the media reduce. Let the oxygen diffuse out inside of this anaerobic chamber. So let's do this now. Open the pass box. Kind of tricky is when we put the liquid media into the pass box, we have to open the lid a little bit, though that may have the risky of contamination, but it is important to let the vacuum and the nitrogen flash to go inside of these tubes. Let them let the oxygen diffuse out quickly. So now I kind of turn the lid out a little bit and put it inside. Also, we would put in other necessary materials like fermentation tube, the rubber stopper. And close the door. And here's an automatic start button, just hit it once. It will automatically go through the vacuum, nitrogen gas purging, vacuum, nitrogen gas purging, that cycle again and again for 3 times. Once it's finished, press that button again to make a total 6 cycles of vacuum and nitrogen gas purging. To make sure inside of this small pass box it's kindly 99.9% anaerobic.